All right, 11.3 is about combination. So last time we talked about permutations. Permutations are what you use whenever the order is important, and combinations, it's not important. All right, so again, so the formula is on here, and it's similar to the formula for permutations. So the only difference between the formula for combinations and the formula for permutations is this R factorial right here. So that's like dividing out for the order. So like with a combination, if you had say like red, green, blue, that would be the same thing as blue, green, red. Whereas if with a permutation, those would be two different things. All right, so, but again, you don't really have to use the formula if you have your calculator. We want to do 10C6. So we just type in 10 and then press the PRB button and then use the arrow to underline the NCR function, hit enter, and then 6, enter. So that's 210. All right, so I could change that 6 to a 4. Excuse me. So I find that interesting that 10C6 and 10C4 both equal 210. And that happens because 4 plus 6 is equal to 10. So that's just something that happens with that function. And let's compare that with 10P6 and 10P4. Oops. So 10P6 is 151,200. So significantly larger than 10C6 because with the P, it's taking into account, like I said, the different orders of things. Oh, I'm sorry. No, thank you for letting me know that. And then 10P4 is 5,040. All right, any questions about that? Okay, so here's a couple examples of where you would use this. So number 2 says, in how many ways can a 3-person committee be selected from a 10-person club? So you would just do 10 NCR 6 or NCR 3. All right, and this is a combination because it's a 3-person committee. So there's no, if you have a committee, there's no order to it. It's just a group of 3 people. And that's why I use a combination instead of a permutation. and that's 120. So combination is when the order is not important, and a permutation is when the order is important. So just common sense, just by reading the problem. So it's a 3-person committee. So a committee is just a group of people. Like there's no order to them. So if I said like Joe and John and James are on the committee, I mean, there's no difference than if I said James and John and Joe are on the committee, or Joe, James, and John. There's no particular, if I select a committee of people, there's no particular, I didn't know order to that. It's just a group of people. So if I said, you know, we have to select the president, the vice president, and the secretary, there's an order, there's a hierarchy order to that, right? So that would be a permutation if it was like that. All right, so number 3 says, if Jimmy has 20 toys and is allowed to take 4 with him on vacation, how many selections are possible? So we're just going to do 20 NCR 4. All right, so he's just taking 4 toys and he's just putting them in the suitcase. They're not in any particular order. So that's why this is a combination. All right, so if it said that he's going to take those 4 toys and arrange them and line them up on a shelf, then that would be, you know, you would do that in a certain order. Or if you said you're going to take those 4 toys and you have to select which one you're going to play with on each day of the week. Like on Monday, I get to play baseball, and on Tuesday, I get to play football, and, you know, put them in an order like that. But in this case, it just says he's just taking them with him on vacation. So he's just throwing them in a suitcase. There's no particular order. All right. So that's it. That's it for 11.3. And we will move on to probability in 11.4 through 11.6. Yeah, all of 11.1 through 11.6. Okay, so 11.4 through 11.6 are all grouped together in one set of notes. I think they might be all grouped together in one homework. I can't remember for sure, but it's all about probability. So probability is a measure of the likelihood of a random phenomenon or chance behavior. Probability describes the long-term proportion with which a certain outcome will occur in situations with short-term uncertainty. Every probability has a value that is between 0 and 1 inclusive. So that means the probability can be equal to 0, or it can be equal to 1, or more likely it will be equal to something in between 0 and 1. Okay, so it'll be expressed as a fraction or a decimal between 0 and 1. A probability of 0 means that that particular event is impossible, and a probability of 1 means that that event is an absolute certainty that it does occur. All right, so here's an example. Suppose a fun-sized bag of M&Ms contains 9 brown, 6 yellow, 7 red, 4 orange, 2 blue, and 2 green candies. Then suppose that a candy is randomly selected, and we want to calculate the probability that that is yellow. All right, so first of all, we need to add up all the different colors to see the total number of candies in the bag. So 9 plus 6 plus 7 plus 4 plus 2 plus 2. All right, so let's add all that up. So that's a total of 30. So there's 30 M&M candies in that bag. All right, and the question is, if you select one at random, what's the probability of it being yellow? Well, there are 6 yellow ones out of 30. So that would be 6 over 30. And then I would reduce that. So 6 goes into 6 one time, 6 goes into 30 5 times. So that's 1/5. You could also express that as a decimal. You could just do 6 divided by 30 or 1 divided by 5. Either way, it's the same answer of 0.2. So that is exactly equal to 0.2. So just depending on, what the instructions would say, it'll either say, it might say give the answer as a simplified fraction, or it might say, if it says round your answer to the nearest whatever, that means you would put a decimal. Or if it doesn't say, you can just use either one. Okay. And then, all right, so if a candy is randomly selected, what is the probability that it's blue? So there are 2 blue out of the 30. So 2 over 30, and that reduces to 1 over 15. All right, so if I try to do this as a decimal, it's not going to come out evenly. I would have to round it off. But if it said round it to the nearest, 100th or whatever, you could do it that way. But otherwise, I would probably prefer to leave it as a fraction. So it'd probably be best to just do that as a fraction. Like I said, if it specifically says round it to the nearest 100th or 10th or 1,000th or whatever, then you could do that. But otherwise, I'd leave it as a fraction. What is the probability that it's purple? All right, well, unfortunately, there are no purple M&Ms in this bag. So the probability of that is equal to 0. And if one of those candies is randomly selected, what is the probability that it is an M&M? 1. They're all M&Ms. All right. All right, number 2 says, suppose you roll a 6-sided die. What is the probability that you roll a 2? Okay, well, that would be 1 out of 6. What is the probability that you roll an odd number? Okay, well, you have 1, 3, or 5. So that's 3 options out of 6. And that reduces to 1/2. What is the probability you roll a number greater than 2? Okay, well, that would be 3 or 4 or 5 or 6. So that's 4 options out of 6. And we can reduce that to 2/3. What is the probability you roll a 1 or a 6? Well, that's 2 options out of 6, which reduces to 1/3. What is the probability that you roll an even number or a number less than 2? Well, an even number would be 2, 4, or 6, and a number less than 2, the only option for that would be 1. So that's 4 options out of 6, which reduces to 2/3. All right, number 3, suppose you draw a card from a standard 52 card deck. What is the probability that you would get a heart? Okay, well, the deck of cards is split into 4 suits. Split evenly into those 4 suits, one of which is hearts. So if you think of it that way, then you would know that it's 1/4. But you could also say that there are 13, each of those suits is 13, like there's 13 hearts, there's 13 diamonds, there's 13 spades, there's 13 clubs. So you could say 13 out of 52, which reduces to 1/4. All right. Also, you can use your calculator to reduce those fractions for you. So if you put in here, so this button right here acts as the fraction bar. So if you put 13 ABC 52, all right, so that's showing like a fraction, 13 over 52, and hit enter, and you can see that it reduces it to 1/4 for you. So if you don't, if it's not an easy fraction that you can reduce just off the top of your head, you can do it this way. All right, what is the probability of drawing a black card? Okay, well, exactly half of the deck is black. So basically it's going to be 1/2. Or you could say 26 out of the 52 cards are black, which reduces to 1/2. All right, what is the probability of drawing a face card? Okay, well, face cards would be Jack, Queen, King. And so that's 3 face cards in each of the 4 suits. So 3 times 4 is 12. So there's a total of 12 face cards out of 52. And you could reduce that in the calculator. 3 out of 13. Yes, ma'am. So like 12, and then press, for the fraction bar, you press this button right here, the ABC button, and then 52, and then hit enter, and it gives you the reduced fraction. All right, what's the probability of getting a 10? So there is 1 10 in each of the 4 suits. So that means there's a total of 4 10s out of 52, which reduces to 1 out of 13. Okay, what's the probability of getting a red jack? So that means it's either going to be the jack of hearts or the jack of diamonds. So that's 2 options out of 52, which reduces to 1 out of 26. All right, what is the probability of getting a 2 and a 3? Well, you're only drawing 1 card, so therefore the probability of getting a 2 and a 3 is 0. The probability of getting a 2 or a 3, so there's 4 2s and there's 4 3s, so that's 8 out of 52, which reduces to 2 out of 13. Okay, and then what is the probability of getting a 5 or a club? Okay, well, there are 4 5s in the deck, plus there are 13 clubs in the deck. However, one of those is the 5 of clubs. So that particular card called the 5 of clubs is included in the 4 5s, and it's also included in the 13 clubs. So we don't want to count the same card twice. So we're going to subtract 1. So it's kind of like we're subtracting the intersection there. So that means that's 16 over 52. So that would be 4 over 13. I can't find. Oh well. Okay. All right, number 4 says 96 people were surveyed. If one person from that survey is randomly selected, find the probability that the person is a female Republican. Okay, so there are 17 female Republicans out of 96 total people surveyed. So we can check if that can be reduced by putting it in the calculator. 17 ABC 96. No, that can't be reduced. So it might say, let's just pretend that it said round this to the nearest hundredth. If that was the case, I would just do 17 divided by 96, and then that would be 0.18. So if it didn't say that, or if it just said simplified fraction, it would be 17 over 96. If it said round it to the nearest hundredth, then it would be 0.18. All right. What if you randomly select one of these people, what is the probability that the person is a male? So there's a total of 51 males, out of 96 people. So let's see if that can be reduced. Yes, it can be reduced to 17 over 32. All right, and if we wanted to do this as a decimal, 17 divided by 32 is approximately 0.53. All right, if one of these people is randomly selected, what is the probability that that person is a Democrat? And there are 50 Democrats out of a total of 96. Let's see if we can reduce that. That reduces to 25 out of 48. And if we wanted a decimal, it's approximately 0.52. All right. All right, if we randomly select one person, what is the probability the person is a male or a Republican? So there's the males and there's the Republicans. So basically what we want to do is we want to make sure that we don't count the male Republicans twice. So one way to do this is we could add 29 plus 17 plus 22 and put that all over 96. Or that would be the same thing as saying 51 plus 46 minus the 29. So basically, adding the two together and then subtracting the intersection. So either way, that should give us the exact same answer. So either way you do it, it's going to be 68 over 96, which reduces to 17 over 24. Which is approximately equal to 0.71. All right, any questions about that? All right. All right, so if one of these people is randomly selected, what is the probability that the person is not a male Republican? Okay, so one way to do this in this case is add up everything besides the male Republicans. So we could add up 17 plus 22 plus 28 and put that over 96. Or another way to do it, anytime you have the word not, the probability that something is not something, what you could do is you can do 1 minus the probability that it is a male Republican. So that would be 1 minus 29 over 96. So, and sometimes there will be times when you have to do it this way. In this case, we could do it this other way. But either way, it's going to be the same answer. So like if we're going to do it the second way, I would type in 1 minus 29 ABC 96 and get 67 over 96. Okay, and if it's giving it to me that way, I know it can't be reduced. But if I wanted to get a decimal, I could just use 67 divided by 96, and it's approximately 0.70. Okay, and part F, what is the probability that the person is a male or a female? All right, well, according to this survey, there were no options outside of that, so the probability would be 1. And what is the probability that the person is an independent? So 0, because according to the survey, there weren't any, or there wasn't an option, so 0. All right. All right, next we're going to talk about odds. All right, so odds could be written this way, like with a colon, A to B. A lot of times, though, they may ask you to write it as a fraction, and so that would be written as A over B. All right, so if you're calculating the odds for event E, then A is equal to the number of ways that that event E can happen, and B is equal to basically the number of ways that it doesn't happen, which is the total number of possible outcomes minus A. And then odds against event E, B is the number of ways that E can happen, and A is the total number of possible outcomes minus B. Okay, so suppose a 6-sided die is rolled, find the odds for rolling a 2. Okay, well, there is one way that that happens. There's only 1 2 on there. And then how many ways does that not happen? There's 5. So 1 way to roll a 2, 5 ways to not roll a 2, basically. So when you add those together, they'll add up to the total number of possible outcomes. And like I said, it's a good chance they'll ask you to write this as a fraction, so it would be 1 over 5. And the odds against rolling a 4 would be 5 to 1, or 5 over 1. And the odds for rolling an even number, so there are 3 even numbers and there are 3 odd numbers or non-even, but you would reduce that, so it would be 1 to 1 or 1 over 1. And then the odds against rolling a number less than 6. Okay, so that means how many numbers are not less than 6? There's 1. So it'd be 1 to 5 or 1 over 5. All right, number 6 says, suppose you are dealt 7 cards from a standard 52 card deck. Find the probability of getting all face cards. Okay, so there's a total number of 12 face cards in the deck. So whenever you're getting a hand of cards, we're going to be using combinations because the order doesn't matter. Okay, so there's 12 face cards, C7, and you were wanting to get 7 of them. And then we're going to put that over the total number of possibilities is going to be 52 C7. So 52 C7 would be the denominator for all of these questions. So 12 C7 divided by 52 C7. So 1, 2, 3, 4, 5. So that's a pretty small probability. All right, what's the probability of getting exactly 2 spades? Exactly 2 spades. Okay, so there are a total of 13 spades in the deck, and we're saying that we want to get 2 of them. All right, but we also have to account for the rest of the cards. So that means that we want to get 5 non-spades. So there are 39 non-spades in the deck, and we want to get 5 of those. And that's still all over 52 C7. So when we're doing this, these numbers have to add up to this number. So 13 plus 39 has to add up to 52, and then 2 plus 5 adds up to 7. Like those numbers add up to that number. 2 plus 5 equals 7. All right. Because there are 39 non-spades. So I basically just said like 52 minus 13 equals 39. So there are 13 spades, which means there are 39 non-spades. And then, yeah, those two numbers have to add up to 52, and the 2 plus 5 has to add up to 7. So 13 C2 times 39C5 divided by 52C7. Okay, so that is approximately equal to 0.3357. All right, and what's the probability of getting 4 red and 3 black? Okay, so there are a total of 26 red, and we want to get 4 of those. And there's 26 black, and we want to get 3 of those. And then that's all over 52C7. All right, so that's approximately 0.2905. And then what is the probability of getting 3 aces? And I should clarify that I mean exactly 3 aces. All right, so there are a total of 4 aces in the deck, and I want to get 3 of those. So then I also need to specify what's happening with the rest of my cards. So there would be, basically I'm just going to say 52 minus 4 is 48. So there's 48 non-spades, or non-aces rather, non-aces. And so I want to get, so the rest of my cards, which would be 4. And that's over 52C7. So again, these two numbers, 4 plus 48, have to add up to 52. And these two numbers, 3 plus 4, have to add up to 7. So that's approximately 0.0058. All right. Suppose 2 dice are rolled. So this picture shows all of the different possibilities that can happen when you roll 2 dice. So it says find the probability of getting a sum of 8. So with this image, we can, let's see. Okay. Here are all the ones that have a sum of 8. They're all on this, on a diagonal like this. All right, and that is 1, 2, 3, 4, 5. And that's out of a total of 36. So that's 6 by 6. Because there are 6 options for the first die and 6 options for the second die. So that's a total of 36 possibilities. So 5 out of 36. And then a sum that is less than 5. Okay, so that means we have those those. So that would be 6 out of 36. Which reduces to 1 out of 6. Okay, and then it says an even number on the first and an odd number on the second. Okay, let's see, an even number and then an odd number. Even number on the first and an odd number on the second. So that would be all those. So that's so that would be all of these. So that would be just 1 out of 6. 6 out of 36 or 1 out of 6. All right, that is the end of all of those notes. So hopefully y'all will get all that homework done this weekend, right?